Welcome to the Mining and Metallurgical Society of America webinar series. MMSA is an association of senior industry professionals who conduct themselves and their work to the highest standards. The society only accepts applicants who have been educated, trained, and experienced in the mining industry for at least 10 years and who have been referenced by a colleague or industry peers. Once a member, a professional may apply to be a qualified person with the earned expertise in one or more defined professions from specific and extended work in their industry. If you are interested in becoming an MMSA member, please be sure to check out our website at mmsa.net for information on the application process. The Society is dedicated to increasing public awareness and understanding about mining and why mined materials are essential to modern society and human well-being. The Society concerns itself with fundamental principles and with problems facing the industry in such areas as legislation, economics and education, as well as environmental concern, labor relations, and health and safety. Representatives of the Society from time to time testify before legislative bodies and provide advice to federal agencies. The MMSA provides continuous professional development opportunity for its members through the QP webinar series. The series provides subject matter expert lectures on a wide range of mining topics and is presented most months of the year. I'm Kristen Guerin-Davy, MMSA member and social media and webinar director. I will be introducing today's webinar. The title of today's webinar is Transformative AI in Mining by Alister Horn, Business Strategy Lead North America Area. Questions can be entered into the chat. The speaker will answer the questions after the presentation is completed. Please turn off your cameras unless you are asking a question. And I'll hand it over to Curtis.
Thank you, Kristen, and good afternoon, everyone. Thank you for joining us today. Alister Horn is a mining engineer with 30 years of global experience in mine operations, economic reserve certification, and project development. Within the past year, he joined Aerial, a company specializing in geospatial intelligence technologies. And as Kristen mentioned, he's a business strategy lead for North America for Aerial. I could also add that Alister serves the MMSA in an executive capacity on council, and we're very, very pleased to have to host Alister's presentation here today as he talks about a subject that is new and rapidly evolving. Alister, please.
Thank you, Curtis. As Kristen mentioned, the title of this talk is going to be AI Photogrammetry, a case study of transformative technology in the mining industry. So, there's been a lot of promise around AI. It's something that most of us have all probably heard about, and some of us might not have a really good sense of what that means for us right now. When we think about AI in mining, the kind of things that we've been promised that would happen would be increased automation of data collection, more rapid and accurate analysis, deeper, more relevant insights as a result of that analysis, existing tools that could be transformed, which is what I'll be focusing on, democratization of data. Hindsight is 2020. When we try to predict what a technology like AI will do, how it will change things on the ground for us in the mining industry, it can be a little bit difficult to imagine what that really is. I'm going to make the case today that a useful way to try to understand this is to think about what changes will come through AI and how that will transform the tools that we already use. And I'm going to argue that photogrammetry is a good case study for this, as we're going to touch on all of these areas that we've been promised that AI will deliver on. Let's take a step back. First of all, what do we mean by AI? So there's been an ascending scale of computer technology. So computers began with transistors. It's basically simple calculation. And then software, which were sets of rules and algorithms to handle those transistors. Those are passive systems. So you enter the prompt, the rules are run, and it gives you an answer from the prompt. AI is a bit different. It's active. It's true machine learning. So AI doesn't simply calculate the answer, but looks for patterns and trends that are related to the prompt that you give it, and then uses those patterns recursively to deliver the answer. So in this way, it simulates the approach that the human mind uses to problem solve and to make decisions. So that is why it's called artificial intelligence. It's an active learning system, not a passive algorithm-driven system. Let's take a step back. First of all, what do we mean by AI? So there's been an ascending scale of computer technology. So computers began with transistors. It's basically simple calculation. And then software, which were sets of rules and algorithms to handle those transistors. Those are passive systems. So you enter the prompt, the rules are run, and it gives you an answer from the prompt. AI is a bit different. It's active. It's true machine learning. So AI doesn't simply calculate the answer, but looks for patterns and trends that are related to the prompt that you give it, and then uses those patterns recursively to deliver the answer. So in this way, it simulates the approach that the human mind uses to problem solve and to make decisions. So that is why it's called artificial intelligence. It's an active learning system, not a passive algorithm-driven system. AI is being used in mining now, even if we haven't noticed it yet. In geologic interpretation, or in some cases reinterpretation of historical data, drill hole data and other data are being used to better model deposits and ore bodies. This in turn leads to optimized exploration, and as a lot of us realize, exploration is a very high cost, very high risk part of the mining cycle. So this is a very deep benefit to the mining industry. It's used in blast performance. It can be used to analyze patterns of rock fragmentation from cell phone images, and then use that to determine blast performance, to propose where the location of the ore zone lies after a blast, and to predict the effectiveness of the blast. It's used in mining equipment operation. It has been for a few years now. We have smart equipment, we have autonomous equipment, autonomous optimized dispatch that all use AI to deliver a better product. It's being used in predictive maintenance, so we can have more effective PM programs. And it's been used in mineral processing. Again, cell phones can be used as sensors. One example is taking photographs of feed on a conveyor belt. Then assessments can be made, analytics can be made based on those images, and then that affects both downstream plant performance and upstream link to the mining operation. One way to tell that the AI boost is coming. This here is a graph from the S&P. It tracks several of the S&P indexes, the 500, the Information Technology Index, and the Global Mining Index. And we've got October 2022 as the launch of consumer grade, commercial grade large language models such as ChatGPT. And we can see a pretty distinct rise in those indices. Some of this we have to be careful of. S&P claimed that they would attribute this to AI. These were years of very low interest rates, but it certainly reflects at least a big increase in investment in AI. So the question is will the promise come after all the investment is made? We're going to be talking today about transformative technologies. So I wanted to just take a minute here to explain what I mean by a transformative technology. I'm defining that as a technology that's adopted and then adapted into an industry with significant and lasting benefits and changes. Going in a chronological order here, water was a technology thousands of years ago used in mining. The ancient Greeks and the Romans used water. The Romans used water for exploration, for mineral beneficiation, and even for rock fragmentation, which I found quite surprising. Water itself was a technology that was transformed when it became steam. So steam formed the basis of of mechanized mining equipment in the early industrial revolution, primarily used to move material and men up and down. That then paved the way for large-scale mechanization. So the later industrial revolution was able to make use of fossil fuels, either directly or to drive electricity. And that led to the use of widespread mobile equipment in the mining industry. So this is a change that we have with us now to this day. The digital age brought the transistor, which allowed very rapid and lossless reproduction of information. And that then led to the software that we're all used to using. So geologic modeling, mine design and planning, economic modeling, equipment management and dispatch, and many of the other tools that we use day to day in the mining industry. In my opinion, mining is ideally suited for AI. Two factors. The first factor is that mining is highly energy intensive. You've got to move rock very long distances, either from the stockpile to the pit, or either from the mine to the pit, or the mine to the stockpile, and then to the plant, and then again to market. So large amounts of rock and metal get moved long distances. Because of this, mining's history of adopting technology has really been a history of reducing labor. And this graph shows us how effective that's been. This tracks the This tracks the estimated manpower, man work hours per ton mined since 1900. It's dropped from around 4 man hours per ton to less than 0.1. So this is about a 50-fold decrease in the labor intensity of moving a ton of material. So mining's adaptation of adoption of technologies has been very much behind reducing labor. The second factor is mining is a bulk commodity, and it also requires very high capitalization. So for these reasons, it's a highly competitive industry. So there's been, since the earliest days of financed mining, there's been it's been embedded into the mining culture to track metrics. So these are two good reasons why AI, I think, will stay. AI is going to be reducing labor in some areas, and it requires a lot of data. It's very metrics and data intensive. So these two factors, I think, make mining ideally suited for AI. How might it impact mining? We talked about this a little earlier. Again, more holistic planning, better productivity in equipment, predictive mitigation in safety and compliance issues, establishing a more live link between the mine and the plant, better maintenance and deeper insights. What I want to talk about now is photogrammetry as a case study of a transformative technology. I think this is a perfect case for this, and I'll be getting into the areas that we've talked about already that the photogrammetry covers. It's been used for many decades. It's a very well-established tool, but it was a difficult tool to use. It required airplanes, pilots, a lot of scheduling, high costs, specialized equipment, expertise in using that equipment, and it was time-consuming and not particularly accurate. So that it was only used in quite special occasions, usually to survey very hard-to-reach areas or to perform very large-scale or long-term volume reconciliations. But as we're going to see here in the next few minutes, photogrammetry is a very different tool now than it was even just a few years ago. Let's take a moment here and talk about what photogrammetry really is. So when I'm talking about photogrammetry, I'm mostly referring to stereo photogrammetry, and most of us rely on this without even knowing it. Stereo photogrammetry is the principle behind parallax, which is how the human vision perceives depth. From a geospatial perspective, photogrammetry is taking two overlapping images, finding common points on those images, knowing the position of the camera that took those images, and then using trigonometry to assign elevations to those common points on the image. So in effect, what you're doing is taking a photographic image and turning that into a 3D surface. There's a long history to photogrammetry. Terrain mapping using photographs began in about the mid-1800s, and by the late 1800s, there were procedures in place to turn this into 3D mapping. But at that time, they were all done from topo-level photographs. The Franco-Prussian War, and then later, just after that, the World War I, at the same time began using aerial photography for military reconnaissance. So sometime around World War II, those two technologies came together to have aerial photogrammetry. After World War II, stereo photogrammetry and aerial surveying became a lot more closely entwined, and by the 1960s, aerial photogrammetry was being used in some instances in the mining industry. Computers were brought on around that time to speed up the process once they became cheap enough. But cost and effort and convenience in stereo photogrammetry was a barrier through until the early 2000s. And around that time, satellite stereo photogrammetry became more commercially available. So that began to open the door for more widespread use of photogrammetry. And then again around 2010, some more technologies came up that allowed photogrammetry to be more widely used in mining. There are three phases in the process of photogrammetry. The first phase and the last phase are collecting data and then sharing and output of and analytics of that data. On the collection side, the changes in technology that came were commercial and consumer grade drones and cheap, accurate, high definition digital imaging. Then on the share side, cloud computing became a much more widespread technology. We've got to remember that photogrammetry produces very large amounts of data. So the cloud computing, the sharing of the data is a more important part of the process than many of us realize. We're going to look a little later on today at an example of some work that Aereo had done that produced 100,000 images per survey iteration. So there was a tremendous amount of data. And without finding a way to be able to rapidly upload and distribute that data is a big constraint to photogrammetry. The middle part of that process is analyze, and this is where AI has come in. AI is used in the analytics of uploaded aerial survey data to do accurate QA, QC control, for enhanced automated feature detection, which improves the accuracy and allows inventorying of features on those images. It allows much more accelerated processing of data, and compliance and change detection algorithms to be run that allow us to see how surfaces have changed over time. And also AI is being used to generate the first pass of analytics. So you're not just being fed a 3D surface, you're being fed a customized report with various analytics that you've trained the AI to pick up for you. So how has AI transformed photogrammetry? Conventional photogrammetry is expensive, it's inconvenient, you have to get a plane and a pilot. It's manual, it's slow, it requires expertise and specialized equipment, and it's not very accurate. AI-driven photogrammetry is low cost, it's rapid, it's automated, it's very accessible. You do not need to be trained, you do not need experts in it, and it's very accurate. And how has AI transformed photogrammetry as a tool? Conventional photogrammetry was used, as I mentioned before, in special case applications. So very hard to reach areas where you can't get a survey crew, or very long-term reconciliations. Those are the primary uses of photogrammetry. Photogrammetry now has been transformed into a much more short-term tool. So you can get near real-time data. It can be used for short-range planning on a daily or even a shift basis sometimes. So it's become much more of an operations management tool as opposed to a long-term reconciliation tool. I want to give an example here of how transforming the tool of photogrammetry has unlocked value. One of the projects that there are several companies that are using aerial-based photogrammetry. So there's a company called Strauss, one called Propeller. Aereo, the company I work for, is I think leading the field in AI-driven aerial photogrammetry with a focus on the mining industry. So an example of some of the work that AI-driven photogrammetric platforms can provide. Aereo are involved in a project called the Kavda Energy Park. So that is a 30 gigawatt solar and wind power energy park being constructed in Gujarat in India. To give you a sense of the scale of that, the wind farm that you drive past on the highway is typically 10 to 50 megawatts. So this is a 30,000 megawatt project. So very large construction project. When it's finished, it'll provide electricity to 20 million homes. The project is being constructed right now. It's over 500 square kilometers. Ground was broken on that, I think, a year or two ago, and it was quickly realized by the managers of the project that land surveying was going to constrain the project, maybe even bring it to a standstill. On-the-ground crews were being hindered by marshy, wet conditions. There was no access. The roads they needed weren't open. That part of India can get very cloudy, particularly in the monsoon, so satellite photogrammetry could not be used to save the day. There was very poor connectivity, data was being jammed up, and there was an enormous base of users and stakeholders. So hydrologists, geologists, environmental engineers, construction managers, community outreach officers. No one was getting the data they needed. So this project was running the risk of coming to a standstill when it just began. Aereo were asked to come in. They broke the project up into 3 phases: data gathering, AI-driven data processing, and then data sharing. They were able, for data gathering, once they were up to speed, they were able to produce 100,000 geotagged images per survey iteration with very high precision. They were able to do that with one drone pilot who effectively replaced a 5 to 10 member survey crew who wasn't able to get the job done. So one drone pilot could replace the incomplete work of 5 or 10 land surveyors. And there was greater access and greater availability in bad weather. For processing, Aereo trained their AI to detect the construction features specific to this project. So drill holes, pilings, solar panels, cables, fence lines, roads. And it was able to perform 1 million of those detections per survey cycle. Each one would take about 5 days, and they came back with an accuracy of greater than 85%. With cloud sharing, they were able to eliminate the data jams and produce reports with customized analytics, customized for each user's need, and then immediately and directly provided those reports to them. So they got the project back up on its feet. So conventional surveying had been a major constraint to this project, but using a transformed tool, photogrammetry with AI, this unlocked a lot of the value that was being held up. Another example is work that Aereo did for Coal India. Coal India are the world's largest state-owned coal company. They produce almost 750 million tons of coal a year and provide 70% of India's electricity. They do this from over 300 mines that are dispersed all over India. However, they have no centralized data control, and they were essentially realized that this meant that they were flying blind, and they had identified this as one of the reasons why they were having problems delivering electricity. So I think 3 years ago, they launched the DigiCoal initiative to try to test and plan for how they could centrally control survey data. They started with their 7 major assets, which combined produced 250 million tons a year. And in a 6-month project, Aereo came in, proposed a plan, executed on it, produced 5 million images with a data resolution of less than 2 centimeters, and provided almost 3,000 custom reports with analytics to 400 stakeholders within Coal India. So again, they were able to show that they were able to show a major transformation in the kind of value that aerial photogrammetry can deliver. Looking forward now, it's worth asking what could be the evolution of AI and photogrammetry. Autonomous drones are certainly a thing now, and I imagine will continue to become more so. An autonomous drone, the term in the industry is the drone in a box. So it's a drone that wakes up in the morning, goes out, flies predetermined surveys and flight paths, returns, uploads the data, and is good to go. Survey areas, those flight paths, the accuracy needs of those paths, the timing that the autonomous drone uses, those could be decided more predictively using machine learning. And looking for trends in the data. So a simple example of that might be the drone could pick up, detect changes in excavation of a bench, and based on previous experience, know that the bench will continue to be excavated at a certain rate that drill and blast operations will be tied, that excavation operations will be tied to the excavation of the bench. And the AI could therefore predictively determine where the drone should be flying next and be more efficient in dispatch. There could be much more effective safety and compliance issue detection and flagging, looking at predictive data, and an increased use of accurate digital twin models. So this is something that is being used in some industries. A digital twin is a near real-time, highly detailed model of a business or a process that can then be queried to test for how to optimize it, how to detect safety problems, how to detect production problems. AI-driven photogrammetry could be a very important part of a mining digital twin model. So what conclusions can we draw from this? Well, there's an arc of technology in mining. The early technologies were behind reducing labor. The technologies in use of computers were to generate insights. What I think AI will be doing will be driving us to be making better decisions, so higher quality decisions, and potentially decisions that we would not have been able to make without AI to help us. I think one way to understand how AI is going to change mining is to think, it's useful to think, how will tools that we currently use be transformed? What will happen to them with the use of AI? And photogrammetry is an example of this. This was transformed from a special use niche technology to an everyday operations level management tool. With these better decisions, that will impact mineral economics and mine production and which mines come, which mines go. And I believe AI will have an irreversibly deep change on how we manage and exploit our mineral wealth.
Excellent, Alister. Thank you for that. Question I had, Alister. Obviously you introduced the concept of AI in the mining industry, and then a case study a little bit narrowly focused on photogrammetry. What are some of the other areas that you are coming across already that are starting to adopt AI and machine learning into the operational management of mining, open pit or underground mining operations?
Underground, did you say, or just
open pit or underground?
Any mining? Geologic interpretation, for sure. So there are several companies. I understand Ivanhoe has really gotten into this. So it's using an AI to either interpret current drill hole data or reinterpret historical data, and then geologic modeling based on those reinterpretations of the drill hole data, taking into account not just drill hole data, but water data, any metrics, if there be mining in the area, any metrics from the mining. So geologic modeling has been a big part of it. Another one that I've been hearing of more recently, which I think is an area that there's been very little work done before AI, was using just a handheld cell phone to take photographs of feed on a conveyor belt, and then have the AI make predictions about what grade that might be, how the fragmentation was, and then it informs both downstream processing performance and also provides a link from the plant back to the mine.
Yeah, something like that. It's done with belt scanners now, fixed belt scanners to collect. But I think that the key point that I'm hearing from you is that there are various collection tools around and various sharing tools around, and it's the AI piece that joins the two up the middle with the analytical strength and power of it.
I think that's a good point. I mean, if you look at drone surveying, I mean, drones have been around for a while now, so that was inevitable that would be used. And then cloud computing is being, that's already well established. But AI was able to draw those technologies together to then, really transform what photogrammetry was, or what photogrammetry is.
No, good. Thanks.
Sure. Can you give me like this what you talked about is the reconciliation issue, right? Do you know any example where they're implementing it?
Of reconciliation?
Like you said, to take the image from the conveyor belt and stuff. I know what Curtis was talking about. That's implemented in many mines. Actually, in Africa, I've seen a few mines, and but run by the bigger mining companies, and also in North America, few projects that are doing that. But when it comes to AI implementation, in my own observation, is way. I mean, that are testing it. I mean, there are actually. Do you know any operations? Really, I'm trying to learn actually where they have done it. Anything
Well,
for a reconciliation problem?
for volume reconciliation.
No, mainly quality. Volume reconciliation is not a big problem. I mean, we are doing it anyway. But mainly quality. Mainly quality, because once the commodity changes, quality variation is substantially unpredictable.
Yeah. So I mean, if we're talking, are you talking about reconciling the head grade quality to what was planned?
Mm-hmm. Yeah.
Yeah.
Do you know any examples of that where AI is implemented?
I can't. I'm not sure I can give you the names of clients, and I can't tell you exactly what they have been using AI for, but or photogrammetry for. It certainly is something that you could build into it, so you could certainly use it for that.
Mm-hmm.
One application here, Abani, would be to, for example, run of stockpile grades. That's a very difficult thing to accurately get a grip on. With using photogrammetry, you could be tracking what's coming from the pit, and then tying that back to your model to see what the grade is, or potentially tying that back to the lab if you're able to do continuous assaying or continuous quality testing. And then you can also reconcile what comes excavated from the pit to what is deposited in the stockpile. And then you can build a 3D image that reconciles the two.
Well, yes, actually, Alister, actually, what you're saying that we could do, there are actually few companies I know that are building tools for specifically addressing a couple of things. In reconciliation, if you map the whole value chain, there are all different main five nodes in there. Tagging is very difficult. One of the main thing is whenever we used a scanner technology, it only got the information for maximum foot from, you take it from the stockpile, you take it from the truck bed or whatever. Because basically the variability is not captured. That's what I was asking. Because you are into AI, I'm saying, is there any particular solution that's being available? You don't. I understand you don't need to, and I'm not interested to know your client list. But particularly technology, anyone or anywhere, actually, any place it is implemented, it looks like it's still in the working. But that's a reconciliation is a complex thing, right? I mean. I understand what you're saying. We'll leave that, but we'll probably reach out to you later on to have a discussion offline. Thank you.
Yeah, I think just to close up, Abani, I think that the constraining factor in what we're talking about here is getting actual quality as opposed to model quality. But certainly the step where you're tying quality of specific volumes between what's in the stockpile and what's in the pit, that would not be able to be done with a land surveying crew. Whereas
exactly that is the point actually, because the blasting company, the two major blasting companies, they have their own AI tool, or they're building one, or they have a IT tool built. Now they're selling those products. And also there are smaller AI companies coming from US and Canada. They're also focusing on the blasting and how the products move, what the type of quality, those kind of things, right? But when I try to tie together, to map the whole value chain, to give the assurance to the operators, like, okay, here is the scenario. I'm not saying good or bad. Here is a scenario in the mine. I get lost. No, we are not ready there. I guess we are talking about something, right? I guess we need some more time for the tool to be developed completely.
Yeah, I mean, it might be a sort of all of the above solution where you make a first pass prediction based on what you think the quality is in the model.
Yeah,
Then you true that up by reconciling what feed is going over the conveyor belt to what came from the stockpile.
because there comes the fundamentals of AI technology, right? All the AI technology, it doesn't matter what, is based on the statistics of the data that you are training your tool. It doesn't matter what you do, right? That statistics has to be based on the rich data, very rich data, and that rich data you are training. That means you're talking about a few years of production need to be fed in. For it gets complex. I don't want to get into weeds there, but you understand, right? I guess. Well, agreeing to the fact that we got to develop make some smarter tools so that it can be implemented. Because that's always my headache actually. When I get a call like there's a problem in the production, then is reconciliation. How do I reconcile it, right? How do I do it timely manner? That's always a pain. But thank you, Alister. It's very interesting.
Yeah, that's a great question. Thank you, Barney.
Alister, I had a question for you. I know in my experience, which was more on the machine learning side, change management and technology acceptance was a huge obstacle to overcome. How are you or your company working with this to ensure the miners and companies are trusting the results without extensive double work or rework?
I think double work and rework is most engineers worth their salt are going to say. But I think a lot of it is over time. Once they get the tool, use it, check it for a few times, they start to trust it more. I think the one for photogrammetry as an example, one really important thing here is that I use the word democratization. It's you don't need an expert in order to you can train the AI to provide you you can have someone train the AI to then provide you the insights that you're looking for. So it's the foreman can go out with his phone, take a photograph of some rock, have the AI tell him what blast fragmentation is, and it's just analysis. It's numbers, so it's likely to be right. It's as good as you train it, obviously, but it does mean the disadvantage in it being a bit of a black box, I think, is outweighed by the advantage of how usable it is. But of course, everyone should be having their systems to check, to do a truth check on what they're getting. I honestly think that's a pretty good rule for AI in general.
Yeah.
Another observation, Alister, is we hear all the time about the large language models and ChatGPT and whatever other ones are out there, and now we're starting to hear about how they hallucinate and feed back answers that they think you want to hear, as compared to the correct answer or a challenging answer. And I think there's a distinction to be made here between large language models and what they do and AI tools that are different than just large language models that are truly analytical models or algorithms like you mentioned.
I think that's a very good point, Curtis. I mean, there are lots of different ways of running AI. A large language model takes letters, alphanumeric letters, converts them into numbers, and then is just running a numbers game. The large language models, for example, if you give them a math problem, are horrendously bad at solving math problems using language, but they're very good at finding patterns in language. The kind of AI that we use in Aerial, for example, to look at survey data is not large language model type AI. It's more numbers based. It's more metric based, more mathematical. But it's a very good case. We use AI, but that term covers a lot of different approaches to machine learning.
I guess Alister, that connects to what Curtis is bringing up, and you said that those matrices, these are key, right, in your AI model, and how you develop those matrices is again coming back to those statistics. Actually, how you train your model, isn't it? I mean, those key factors in the matrices, right? I mean, AI tool is very successful if you have to set the matrices well. I mean. Same example, you ask the ChatGPT, few times the same question, it's gonna give you the answers. Like, I get bored actually. What is it doing for me? Even doing the small things, right? Yeah, metrics development is something, you know, we need to be very careful, particularly in the mining industry, because we're so variable. If we're able to talk, that's a good question, Curtis.
These are early days. When you think about the changes from early computers to modern computers and the sophistication of how circuit boards are laid out, I mean, AI, I imagine, will go through a similar thing. It'll become more sophisticated as time goes by. I used to pride myself on being able to tell AI slop on the internet from real slop, and I can't do that. I mean, it's been a year or two, and I'm not as good as it as I used to be. So give it 10 years. It could be AI. The kind of mistakes that we're seeing now in AI, I think, will be getting less and less.
Great discussion. Are there any other questions? I'm not seeing any in the chat.
Does have questions, or if anyone wants to talk or reach out to me and discuss AI use in mining more, you can get my information through Kristen or through MMSA, or you can reach me at LinkedIn. But I'll be happy to talk to anyone about this.
Great. Well, many thanks to Alister for their excellent presentation, and thank you for all who attended the webinar. All of our webinars are uploaded to YouTube and can be accessed through the MMSA.net website. The video of this webinar should be on the website within a week. We will post it on our LinkedIn pages when the video and slides are posted. Our next webinar will be in February by Justin Norman on project management for mining capital projects. We will post the PR for this next week on our website, LinkedIn, and Eventbrite. The MMSA webinars are supported by the MMSA Jackling Foundation. Again, if you're interested in becoming a member, please be sure to check out our website at mmsa.net for information on the application process. The webinar is now ended. Thank you.